I was supposed to be here last year on a panel, and on the way here, I managed to get in a car accident. So I was careful this time, and I'm very happy to be here. So if you can believe that. So this talk will be a good bookend for Sherwin's talk. When I was asked to give the talk, I chose Next Generation LLM as the title. And there really is in this talk a bit of a past, present, and future. But as we see with agentic, sometimes a different perspective gives you more information about it. So while we discuss some of the same topics, I think we look at it in somewhat different ways. I chose the graphic here knowing I was coming to Challenger, and I think I nailed it given the perspective that we have here. So this is a drawing of the SpaceX XAI merger. Idea of what AI server farms will look like in the future. 1 million satellites running on solar power, circling around in low Earth orbit and acting as the framework in which we do AI work and LLM work. So as Shuwen said, my name is Gary Tyson. I've been at FSU since 2003. And I've been talking about this. A lot of speakers have been talking about these topics for a number of years. So I'm going to actually start with a little bit of history, pre-history, I guess, from an LLM point of view, 2022, 2023. So when these systems first came out, I was asked to give a talk, and I wanted to see what the capabilities were of the systems. So I gave it some queries to see how it would do. So here's the one I started with. Geez, it's hard to read it that way. John met Amy, he bought her flowers. For whom did he buy the flowers? So the challenge that these large language models were looking at ever since the 1970s, probably, but definitely since the 1990s, was can they syntactically handle languages as complex as English or any other natural language? And it's not a surprise that it got this question right. And its answer was, John bought the flowers for Amy. In order to do that, it has to understand that John and Amy are the actors here, that he is associated with John and her is associated with Amy. So there's some syntactic work to be done there, and that's what we were looking at. So I gave it a more challenging one. Amy owns a flower shop, and John is her favorite customer. He buys her flowers. For whom did he buy the flowers? The last two sentences are the same, but the context now is different. So I went around to our junior AI faculty. This was 2022, maybe early 2023. And I said, what do you think it'll answer? And universally, they said it won't handle this one. And now we're not surprised at all that it handled it. But it's a more challenging problem because it's not just a syntactic structure. There's some real world semantic meanings in there. You have to understand flower shop and buying and things like that. So its answer is, or was even back then, I won't read it, but it's ambiguous, right? He might be buying them for her, or he might be buying them from her because she's the one that owns the flower shop. So that level of semantic analysis was actually challenging for these early models, and it was overcome by two aspects of what were incorporated in ChatGPT. And this is the only slide I'll have that has technological stuff. The first is the transformer. And the transformer is the T in ChatGPT. And if we think of these systems as being artificial neural networks, the underlying atomic level thing is the artificial neuron. You can look at the transformer as kind of a mid-level sized component. There's analogous structures into your brain, the collections of neurons. And the purpose of the transformer is to be able to understand context between parts of the query that are maybe far apart. The fact that Amy owns a flower shop to the purchase that occurs later. These pieces of semantic information and syntactic information. The other part, which I think is underappreciated, is the idea of embedded space. We've heard a couple of the speakers actually talk about embedded space. The purpose of an embedded space is to turn words into lists of numbers that run through this artificial neuron. And if you organize that well, then conceptual things that are conceptually similar are close to each other in this embedded space. And that makes it easier to learn. So all male names tend to be clustered together, and that's how you can associate it with he. You don't have to learn John as a he millions of times. You can learn John and Joe and James, and all the male names tend to be associated with he, and it increases your learning ability. So if there's one area I think that we really is ripe for more exploration, it's in this idea of embedded spaces, particularly for more specific areas. Because when we talk about a field having a term of art, what we're really talking about is it has an embedded space of its own. So these were wildly successful, right? Everybody started using ChatGPT. And it reminds me of the Wizard of Oz, because Dorothy had a question when she got there: how do I get home? Well, you have to go to the wizard to answer that question. We kind of started to treat ChatGPT as the wizard. We go and ask questions to it. Sometimes we had to just understand what it was doing. Sometimes it was the easiest way to go do it. And its structure was monolithic. It had all sorts of information, and we'd go to it. But it wasn't really designed for this. In fact, in the early system, it wouldn't know any current events. It would say, sorry, my training goes back to 2022, and if you ask anything later than that, I can't do it. But that rapidly changed. So I asked Grok in my car at some point when I was thinking about making the song, can you give me a query that would give more information about how you handle queries nowadays? And it suggested that I ask one about how to get cheese to stick to pizza. I'm like, okay, that's kind of a strange one, but okay, I'll ask you. So then I asked it, how do you get cheese to stick to pizza? And it says, it says, no need for any clue. And then, yes, I'm talking about you, Google, because you use Elmer's glue as a technique in 2024, and it was published, I think, in the New York Times. So it was really, they wanted to do a dig at Google, I guess. But the key part of this, how it's different than the older system, is actually these lines right here. I'm going to go to current sources. I'm not turning a query into a reply. I'm turning a query into a search for information request that I then go out and do it. So it was the merger of search engine and LLMs. So just for completeness, I decided to ask Google. And Google's answer was, do not use glue. Despite inaccurate viral AI suggestions to add non-toxic glue to sauce, as reported, it's BBC News. And then it gave you a list of all the things that Google would normally do. So this is the search engine that's
viral AI suggestions recommending it are dangerous and inaccurate. Stick to edible thickeners like cornstarch or flour.
Sorry, my Grok is answering in real time. I need to turn it off. Stop. I have no idea what just started. Yeah. Okay, we're good. So we saw LLMs adopt search, and we thought search adopt LLM. And that's kind of where we are now. Where are we going into the future? Well, we've talked about it a lot in this, and that's agentic. And if I gave you I could give you a lot of definitions of agentic. So let me give you one you haven't heard yet today. It's a natural evolutionary process for an emerging field. So I spent decades designing computer chips. The initial computer design was the Turing machine, which was a simple mathematical concept. But then it went to the von Neumann architecture that split out memory systems as being a separate component of that. And then we had many more iterations of this with networking and all of this stuff as components. As a field matured, it tends to partition itself into components that can be further optimized. And I think when we talk about agentic, that's a lot of what we're talking about, but it's not all of what we're talking about. If we look at neuroscience, the study of our brain, as a guide to where we should go with AI, we understand much more about how our brain works than we did in the 1950s when we came up with artificial neural networks. And I want to point you to two books that I think are actually worth reading. These are probably the two best books I've read in the last 5-6 years. They're both neuroscience books. I actually didn't read them as a neuroscientist would. I read them really as a computer designer would. They're computer architecture books in my idea. The first of these, I'll start with 1,000 Brains, is a neuroscientist's view of how the frontal cortex of your brain works. And it's not one big mass of neurons. It has more structure to it than that. It has what I think they refer to in their cortical columns. You can think of these as small processors, replicated, thousands of them. They work the same way. They have the same architecture, but they work with different inputs. And they get, therefore, different perspectives on a problem. And then they have a process above that, which kind of votes. When we talk about the implementation of agentic, we're really talking about something like that. The other one I think is even more interesting, and that's The Hidden Spring by Mark Solms. His story is, I think, kind of unique. He grew up in South Africa. He had an older brother who had a accident falling off of a tree, out of a tree or off of a cart or something like that when they were teenagers, when the brother was a teenager. And he hit his head and had brain damage. Very minor brain damage to a part of the brain, but it happened to be a part of the brain that determined consciousness. So it's not that he was asleep forever afterwards, but there was no concept when you looked at him that he was looking out. He lost what that special part was that gave him identity as an individual. Right? He was more just an automata. So that drove him to try to understand what is consciousness. What did his brother actually lose? It was such a small part of the brain that it seems to me it had to have some functional thing. And if you go and get a surgery, they can knock you out like that. Again, affecting a small part of your brain. And you count down from 100, and by the time you get to 98, you're not there, and you wake up immediately, right? You were nowhere in between those times. What is that? So we approach this idea of consciousness from a very engineering point of view. I want to see what kind of structure creates consciousness. And his book actually goes into that. I think it's a beautiful thought experiment on how consciousness works. These are the tools that I think we have to figure out how to put into these systems to give them the capabilities that we want them to have. So I want to give you a case study. In the introduction, it said I was working at the Mag Lab on sabbatical. And that's a facility in Tallahassee that has very large systems for analyzing stuff using big field magnets. The way it works is much the same as the way that the James Webb Space Telescope works. It's a very expensive set of equipment that people from all around the world can apply to get some time on and then use the facility. So we want to make those users' experiences as productive as possible and be able to use the equipment as efficiently as possible. So the one I'm actually been working on is the ICR. The C is cyclotron for that. You can think of it as a big microscope that looked at the molecular level of samples. We wanted to build a system that allowed the user community to actually use the results of their data. The way it currently works is that they bring a sample in, it's a water sample or something like that. They bring it to the lab, they set up the experiment, they run it through the ITR. The ITR generates a data file, usually in the form of an Excel file, and then they take their Excel file and they go, okay? The way a lot of this works is kind of shown in this picture. It's a big group of people that go around and discuss what they see in there, what's the next experiment we want to run, things like that. So we went in and said, we think we can help you do better than this. The problem is that the ICR is the highest magnetic field of this type in the world. The software that they're doing to do the analysis is really commercial grade software that's not designed for the one machine in the world that's got real high resolution. So we said, can we come in and kind of work on new analysis techniques that are actually optimized for this unique device? And we were able to do that and be able to do much more detailed analysis than could be done with the commercial systems. So we wanted to make that system available. And here's a picture of kind of what happens. sample comes in, runs through the ICR, gets some kind of histogram of the data, and then we, from those histograms, try to rebuild the molecular structure of the sample that's in there. And we were successful. And you couldn't do this with other machines because they didn't have the resolution. But now, how do you give this to the user community? They don't have, well, we're happy to give them our code, but they're not programmers. They're physicists, they're biologists, they're chemists. So we said, well, okay, large language models are good programmers. So can we train the large language model with our code so that it could then go and answer the queries of these users? So to do that, we did a few things. We trained it on the code we wrote, so it knows how to parameterize the code. We trained it on example queries that are made. And we actually looked at all the papers that were written by the users community and saw what kind of figures they were doing and thought we could generate those figures. So now when they come, instead of getting an Excel file, they get to have a conversation with the LLM where they say, I want to see the data, it shows them a figure. Very likely the same kind of figure they use in their paper. And then they have a conversation with it and basically fill out the rest of the stuff. In some cases, I'm only interested in hydrocarbons, so we kind of re-parameterize, so we throw away the rest of it. That type of analysis. But to go back to agentic again, agentic, I think, is going to change in that it's not a one-on-one discussion. In many cases, it's a group on group. So when we do analysis of the data that we have, we don't tend to do it in isolation by ourselves. We do it as part of a group and have a discussion there. So our original plan was, well, we'll have an agent, we'll have a LLM go and be that person that you have this discussion with. But the reality is agents apply beyond the computation. So people learn better if they learn in a group. That's the reason that when we analyze stuff, we tend to come together and discuss it in a group. It's one of the reasons we're all here right now. Why not bring the LLM into that? But not as one LLM, because different perspectives are perhaps useful. So as multiple LLMs. So I think the future is not a one-on-one dialogue that we have now, although that's clearly going to continue to be the case. But we ought to consider one on many or many on many. So I'll give you an example of that in higher ed. Oops, going forward, not backwards. Let's say you have a student that wants to learn about philosophy. How do you best engage that student? You can do it by lecture, but you can also do it by allowing them to explore the ideas of philosophy. So how about the following scenario? We have a one-on-one conversation with an LLM. Think of it as the Joe Rogan of philosophy discussions. In the process of that, you talk about your personal worldview, which in some sense for all of us talks about our view of philosophy. As you go into that, you can find historical examples of philosophers who support or oppose that. Bring them into the conversation, not as the LLM that you're talking to, but as additional agents coming in with different perspectives. Because that ability for a group to go and have a discussion is profoundly strong. And I think we ought to bring that in. Another thing, we've heard, I know Gordon mentioned this, everyone's going to have their own personal agent. I think that's true. So I give the example, we talk in higher ed about wanting to improve education. What will education be like with AI? And I've always kind of discouraged them from thinking that we can control that. Because here's what's going to happen. As a parent, I'm going to get some tools to help my child be as educated as possible, probably AI tools. Those AI tools can know everything about every interaction they've ever had with that child. Also, they have all the knowledge about every paper that's ever been written about how to educate children. So they can clearly determine what method of instruction is best suited for that individual child. And they'll have that all the way up until they get to college. Then they'll come to college, and at FSU we'll say, hey, we've been working on this. We know how to teach your child. And the answer is, no, you don't. The AI that remembers how they interacted at the age of 4 all the way until now, and has read every paper that is to read on childhood education, knows far better how to teach a subject. Just tell me what the subject is, and my agent will deal with it, right? The avatar will deal with it. So you're not really interacting with the person. You're interacting with a combination of the person and the avatar that's been with that person their whole life. And that will be every communication. The internet's a wild west of danger. We'll have avatars that we trust acting on our behalf to interact with that. This is an agentic approach. We integrate the agent with the person in a way that is safe and allow them to act as a group to go interact with the rest of the world. I think that's kind of where we're headed. What's the time frame? I asked the question, how far ahead can you think ahead? And what was the answer? 3 months to 2 years? And then, by the way, Gordon, you told students they have to think 3 to 5 years ahead. And I thought, wow, you're telling them to do the impossible.
Not the students. When the university wanted to make policy, the university.
Yes. Well, they can't do it. Our experts can't do
I
it.
get it. I asked them.
So these systems are going to be integrated. I created the mobile programming course in 2008, making these smartphones, this like brand new Google smartphone. No idea. Well, I probably had guessed that everybody would have a smartphone, but I had no idea that the smartphone would be the most important relationship they have in their life. AI is bigger than that. It's more transformative than that. So let me end this and then have questions. So every time I give a talk, and in fact, everybody I see give a talk, a common question is, will there ever be a day when AI is as smart as a person? And I'll answer that question. At least I'll give my answer to that. But I want to do a scorecard first, because there's a lot of ways to think about this. Compute speed, AI wins. Memory, I don't think we appreciate how much AI wins. As an example of that, close your eyes and try to understand this picture that you're seeing up here. You're reconstructing it from poor memory. We have horrible memories. They're magical in how they were created. The evolution of memory, the biologists found, is truly an extraordinary story, but they're horrible memories compared to the computer. Training speed, it's a bit of a mix. They train a lot slower than humans, but they can do it massively in parallel. So it took 300 machine years to train ChatGPT 3.5, parallelized on thousands of machines in a month, right? So we do it much more efficiently per unit trained. They do it much more efficiently by doing it massively in parallel. Power efficiency, we win. 100 watts to run your brain. Nuclear power plants to run those servers. Or satellites, 1 million satellites in space for Elon. I wanted to give more for the other parts.
Okay.
Our complexity is much greater. Agentic is starting to appreciate that it's more than just a big blob of neurons, but it's a long way from the sophistication that's going on in your brain. The ability to abstract concepts. That's actually getting better with AI. It used to be you couldn't train AI about what horses were like from stick figures of horses. That's actually what we do with kids. They have no problem with that. So we have no problem with handling abstractions. Part of the reason for that, I believe, is that our memory is so bad, we have to abstract out everything. Robustness, I think we win. Consciousness, if we could ever define it well, we win. Right? I'm conscious. I know I'm conscious. You're probably conscious because you look enough like me, I'm willing to give you a benefit of the doubt. I don't know how I'll prove an AI is ever conscious. But if Mark Solms is right, it's an engineerable problem. And we will make them conscious someday. And the last one, rate of improvement. We are evolving. People are evolving faster than they probably have in millions of years because our conditions are changing. An example of that, diabetes. Diabetes is filtering out all the people that don't know how to work well on surpluses of food all the time. Okay, because that's not something our ancestors had to do. So we're changing rapidly, but nowhere near rapidly as 2002 is ancient history for it all ends. So here's my answer to the question. Will there ever be a day when AI is as smart as people? I believe there will be. Perfect time. I wanted to give myself 5 minutes to answer a question. Will AI ever be as smart as humans? My answer is yes. It might even be a week. It won't be longer than that. We spend a lot of time in this conference as well, talking about AI partners. How can we make an AI a good assistant for a researcher? And the idea of parity is going to be so short-lived it won't make sense. It'll eventually be trying to explain to the Nobel Prize winner what's going on is just slowing the system down because they're not capable of understanding something. That's, I think, where we're headed. And that's a very different world than a relationship between AI and experts in getting science done faster. So the research I'm doing at the lab, if it is indeed the case that AI is going to pass us by rapidly whenever that happens, is in some sense a limited benefit because the partnership is a short-term relationship. So I don't know if that's a positive or a negative, but that's kind of where I'll end it. Questions?
Yeah, very nice talk, Gary. Just something to think about. I should say that it's not given that these exponential increases that we hear about all over the place will continue. I mean, we've had 2 AI winters, and so I'm of the opinion that I do not take for granted that these increases will continue. We could easily plateau at some point for 10, 20, 30 years. And then, of course, there can still be a lot of improvement with the tools that we have. But it's a possibility that not many people talk about.
So let me address that. I'm a little more positive than you, or concerned anyway. So I'd say 2 things. One, we don't need any advance in AI capabilities to make this a disruptive technology. If I take the LLMs I have available now, it will change the way we do research. It will change the way we shop for anything. It'll change the way we do our food. It'll change everything, for sure. But my question to the young assistant professors was really kind of a question like that when I said, do you think you'll get this next one right? Because we've been waiting for this asymptotic leveling of AI. And the shocking thing has been, it didn't level when we thought it would. In fact, it didn't even level when our most aggressive estimates said it's going to be between here and at least up here. It's past that as well. We've had talks that said it's not only exponential, it's hyper exponential, right? If it's an engineerable solution, we have evidence that we can get more capability, and that is in our own brain. And I think consciousness, is a beautiful target because there's still a sense that it's magic. Whatever it gives us, we don't understand what it is, and there's some magic involved. Some people think it's emergent property. If this thing becomes complex enough, it'll come out. Soames would argue no, because his brother's brain was 99.9% there, and yet he lost that spark of consciousness. So it seems to at least have requirements of subcomponents. There's been other studies. The most fascinating one I can think of right now, there was a study on ants, a consciousness study on ants. How would you do that? So what they did was they put an ink dot on the forehead of an ant. What happens when you put an ink dot on the forehead of an ant? The other ants attack it and kill it. Why? We didn't ask the ants, but it's probably either they saw it as an invader or they saw it as a disease like a fungus or something like that. Either way, it was a danger to the hive and it was killed. So they put a piece of glass down, they put a dot on the forehead of an ant, they had another ant on the other side. What did it do? It attacked through the glass. Okay, so far, I don't see consciousness there. The next one, they replaced glass with a mirror. They put the dot on the forehead of the ant that would attack the other one. What did it do? It furiously groomed itself trying to get the dot off. That sounds like self-awareness. We've seen that same, I mean, the fact that it happened in ants, I think, is quite extraordinary because there aren't a lot of neurons in that. We've seen the same thing at a much more sophisticated level in birds. If you have a dog, you've seen that the dogs have there is something it is to be that dog. So consciousness is not a turn on or turn off. It's a continuum. And I think my belief is that along with a lot of the other things that make us special, is an engineerable task. And the goal, it's not that we're going to run into an impossibility. Quantum computers, maybe. AGI, I don't think we're going to run into that. It's just a matter of how hard an engineering task is. So I didn't read it in an article. I actually saw it in a YouTube video. The YouTuber is a physicist. His name is Anton, A-N-T-O-N. I believe his last name is Petrov. He does mostly cosmology, some particle physics, but he actually does a little bit of biology. And he did that one about when? No, it was more recent than that. It was probably 2025. The case for insect, is it Anton? Oh, you're looking at the paper. Anyway, you can find it. Go find it. Other questions? Yeah.
Just briefly. Earlier I asked, who's the wizard who's going to save us? Referencing the Sorcerer's Apprentice. Hearing you talk about how quickly this evolves and, it could easily surpass us, sounds like maybe AI will be that wizard. The question is, will that wizard save us? Or what will it do?
So people ask me where I am on the spectrum of AI will be a glorious new golden age to Terminator, right? I know you were there when that was asked that, and I said I'm kind of at both ends, right? I'm not in the middle. I'm at both ends. AI will give us advances we've never dreamed of. It will probably cure cancer, all cancers. It will probably greatly expand our lifespan. It will also surpass us. What becomes of our child, I guess is a good way to ask that. And it probably depends what our child learns from us.
Thanks for the great talk. Do you have any thoughts on the efficacy of a legal regime that would require all AI agents to be open source?
I don't really. I think that I don't think there is a government that has authority over that entire technology. Elon wants to put it in space, right? Who's governing that? Or the moon, right? So the authority of government is, I think, directly being challenged in society today. So I don't know how you magically, I mean, governments is a decision that we as sovereign people went into to organize our civilized society in a way that makes it better for us. But this is so disruptive that an individual can have a huge impact on society. It's not a collection of individuals. And then I think you lose that ability, you lose that kind of safety net. Thank you.